Have you ever really listened to the world around you? Take a moment and notice all the sounds you can hear, both loud and soft, near and far. From birds chirping outside your window to the ring of a school bell in the hallway, sound is everywhere, filling our lives with information and excitement. It's how we communicate with friends, enjoy our favorite music, and even stay safe. Like when we hear a smoke alarm warning us of danger. But what is sound, really? It might seem like magic, but it's actually science at work. Sound is a type of energy that travels in waves, moving through the air and other materials. Imagine dropping a stone in a pond and watching the ripples spread out. That's a lot like how sound waves move, except they travel through air, water, or even solid objects. Sound waves move in all directions, carrying energy from the source to your ears, whether you're in a quiet classroom or a noisy playground. Every sound, from the softest whisper to the loudest thunder, is energy moving in a wave, traveling until it reaches something or someone who can hear it. But where does this energy begin? It all starts with vibrations, tiny, rapid movements that set everything in motion. A vibration is a fast back and forth movement, and it's the secret behind every sound you hear. Everything that makes a sound is vibrating. Musical instruments, your voice, even the bell at school. When you talk or sing, your vocal cords vibrate, creating sound waves that travel out of your mouth. When you hit a drum, its skin vibrates up and down, pushing air and making sound waves you can hear. These vibrations push on the air, creating invisible sound waves that travel all the way to your ears, letting you experience the world in a whole new way. Understanding sound helps us appreciate music, solve everyday problems, and protect our hearing in noisy places. It's an important part of science and our daily lives. Science is about curiosity, asking questions, and exploring the world around us. And sound is a fantastic adventure waiting to be discovered. So let's get ready to explore the amazing science of sound together. Let's make some noise, have fun, and learn all about the wonderful world of vibrations. Let's uncover the secret behind every sound, vibrations. Pluck a guitar string, it vibrates, and you hear a note. That's sound in action. Try it with a rubber band. Pluck it, and you'll see and hear it vibrate. The tighter and faster it vibrates, the higher the pitch. Every sound starts with something moving, clapping hands, ringing bells, buzzing bees. Even your voice is made by vibrating vocal cords. Hum and touch your throat, you'll feel the buzz. The key point, sound is produced by vibrating objects. These vibrations make the air, or another medium, vibrate too, sending waves to your ears. Whether it's a drum, a bee, or a loudspeaker, if you hear a sound, something is vibrating. It's a fundamental law of nature. Remember, no vibration, no sound. That's the science behind every wiggle and every note. Vibrations are the universal recipe for sound. Science rocks. Once sound is created, it needs a medium to travel, solid, liquid, or gas. Without a medium, sound simply cannot move from one place to another. That's why, in the vacuum of space, you wouldn't hear anything at all, no matter how loud the source. Most often, sound travels through air. Vibrations push air particles, creating a wave that reaches your ear. This is why you can hear someone talking across the room. Their voice vibrates the air, and those vibrations travel to you. Sound travels even faster in water, about 4 times faster than in air, because water particles are closer together. This means the vibrations can pass from one particle to the next much more quickly, making sound move faster. Whales and dolphins use this to communicate across oceans. Their calls can travel for miles underwater, helping them find each other and share important information, even when they're far apart. Sound travels fastest in solids, where particles are packed tightly. In a solid, the vibrations barely have to move before bumping into the next particle, so the sound zips along quickly. Try this. Tap a table and listen with your ear pressed to it. The sound is louder because it travels directly through the solid. You might even notice the sound arrives faster than if you listened through the air. For your exams, sound needs a medium, and it travels fastest in solids, then liquids, and slowest in gases. Remember this order: solids, liquids, gases. It's all about how close the particles are. The closer the particles, the easier it is for vibrations to pass along. In solids, vibrations pass quickly. In gases, it's slower. Think of it like passing a message down a line. If everyone is close together, the message moves fast. The journey of sound is a chain reaction of particles passing the wiggle along. Each particle bumps the next, carrying the sound forward. That's how sound gets from here to there. Next time you hear a noise, remember the amazing journey it took through solids, liquids, or gases to reach your ears. Sound needs a medium, solid, liquid, or gas, to travel. But what if there are no particles at all? That's a vacuum, like outer space. In a vacuum, there's nothing for vibrations to push, so sound can't travel. That's why space battles in movies are silent in real life. No air, no sound. You'd see an explosion, but you wouldn't hear a thing. Light can travel through a vacuum, but sound can't. The bell in a jar experiment proves this. Remove the air, and the bell's vibrations can't reach your ears. You can see the bell move, but you hear nothing. Without a medium, sound is impossible. So, space is silent, not because nothing happens, but because there's nothing to carry the sound. That's the big difference between light and sound. No particles, no sound. Silence in space is pure science. How do we hear sound? Have you ever wondered what happens inside your head when you hear your favorite song or the sound of your friend's laughter? It's all thanks to the amazing human ear, a complex organ that works like a tiny, high-tech machine. The ear has three main parts: outer, middle, and inner, each with a special job to do in the process of hearing. The outer ear, which is the part you see on the side of your head, acts like a funnel, catching sound waves from the air and sending them down the ear canal toward the inside of your ear. The sound waves travel through the canal and hit the eardrum, a thin, stretched membrane, making it vibrate just like a drum. These vibrations are passed along to three tiny bones in the middle ear: the hammer, anvil, and stirrup, which are the smallest bones in your whole body. These bones work together to amplify or make stronger the vibrations and send them deeper into the ear, toward the inner ear. In the inner ear, the cochlea, a fluid-filled, snail-shaped tube, turns these vibrations into electrical signals that your brain can understand. Tiny hair cells inside the cochlea bend and move with the vibrations, creating signals that travel along nerves to your brain. The brain interprets these signals as all the sounds you know: music, speech, laughter, or even barking dogs and chirping birds. From a simple vibration in the air to a song in your mind, your ear does it all, working every second you're awake. The journey from a tiny wiggle in the air to a sound you recognize is truly incredible and shows just how amazing our bodies are. That's the fascinating science of hearing, something to appreciate every time you listen. Not all sounds feel the same. Some are pleasant, like rain, music, or a cat's purr. Pleasant sounds have regular, smooth vibrations. Our brains find them calming and enjoyable. Unpleasant sounds, like screeching chalk or blaring horns, are loud, sudden, or chaotic. These irregular vibrations make us feel stressed or annoyed. What's pleasant or unpleasant can depend on the situation and the person. A rock concert is music to a fan, but noise to a tired neighbor. Our perception of sound mixes physics and psychology. The wave's properties matter, but so do our feelings and experiences. A baby's laugh is almost always pleasant. An alarm clock, not so much. Sound is both science and emotion. What separates music from noise? It's all about patterns. Music is made of regular, repeating vibrations, organized into rhythm, melody, and harmony. Each note has a steady frequency, creating a pleasing pattern. Music is sound with structure and purpose. Noise, on the other hand, is made of random, irregular vibrations. Think of traffic or construction. No pattern, just chaos. Our brains find music enjoyable and noise unpleasant. Sometimes the line blurs. What's music to one person might be noise to another. For science class, music. Regular vibrations, noise. irregular vibrations. It's the order in the sound that makes all the difference. That's the science behind what we hear. When unwanted noise becomes constant, it's called noise pollution. Noise pollution comes from traffic, airplanes, factories, and loud music. It can damage hearing, cause stress, and make it hard to sleep or concentrate. It affects animals too, disrupting their communication and survival. Whales and dolphins can get lost because of ship noise. Birds in cities sing louder just to be heard. Noise pollution is invisible but harmful to people and nature. It lowers our quality of life and harms ecosystems. Recognizing noise pollution is the first step to solving it. A quieter world is healthier for everyone. Let's learn how to make that happen. We can all help reduce noise pollution. At home, keep TVs and music at reasonable volumes, especially at night. Use carpets, curtains, and furniture to absorb sound. Plant trees and shrubs, they're natural sound barriers. At school, avoid shouting and use quiet zones for studying. Schools can use sound-absorbing materials and plant trees too. In the community, support laws limiting noise from factories and vehicles. Design cities with quiet zones near homes, hospitals, and schools. Every small action adds up to a quieter, healthier world. Science in action means making life better for everyone.